Alright, section 7.1, we're going to be going over identities, Pythagorean, and sum and difference mainly. So, in the textbook, it shows you, and I'm giving you guys a trig cheat sheet, but in the textbook it shows you the basic identities. Every trig function, sine, cosine, and tangent, can be written in terms of one of these three. Cosecant, 1 over sine, cosine, 1 over secant, tangent, 1 over cotangent, and then vice versa. These are also inverses of those. So if you had cosecant, you can write 1 over sine. So that's that one in terms of sine. You have these negative identities, or the even odd functions, and then you have writing tangent in terms of sine and cosine. So basically every trig function uses either sine, cosine, or both. Alright, so that is going to be very important. Now, the trig identities kind of refer back to a circle, because we're dealing with a unit circle. X squared plus y squared equals 1. And so the very first one we get is cosine of a side, which is dealing with the x, and sine squared, which is the y, gives you 1. So this is that first Pythagorean identity. And then if you go further through the text, it shows you how to use this first one and come up with the other two. So if you divide sine and cosine squared by sine squared, and the 1 by sine squared, divide everything through. Sine divided by sine is 1. Cosine divided by sine is cotangent, but since it's squared, it's squared, and 1 over sine is cosine, so it will be cosine squared. So this is another Pythagorean identity. And then you can do the same thing, but divide everything by cosine, and you come up with this new identity. So these three are the Pythagorean identities. So they kind of show you how to come up with them. You only need to memorize the first one, and if you know the reciprocal identities and you divide by either sine or cosine, you can come up with the others. There are alternate ways to write these, so you do need to be mindful. You can subtract cosine, move it over, and so you get sine squared is equal to 1 minus cosine. Or you could subtract sine squared and come up with this version. And you can do likewise with these two. You can subtract 1 and you get this bottom equation, or you can subtract cotangent and you get this top one, and the same thing with this one. So you can manipulate them and be aware they have equivalent forms. They all hold. Alright, these are a few examples, so you can use these to kind of see the process of simplifying these trig expressions. Okay, you can have these in addition to what we're going to do in my math lab. So some extra ones, several examples that you can have and look at and show you what divides out and how to manipulate them. Sometimes it's just trial and error. You try something and then see where it leads you, and if it doesn't work, try something else. Okay, so you got several. So now we're getting into the sum and difference identities. This book spends a great deal of time really trying to show you and prove to you why it works. So they're using a distance formula. They go through a lot of work simplifying, combining, factoring, using a host of different things that we can do, and ultimately ending up with this expression just to prove to you that that equivalent is equal to this difference equation, which is given here. Alright, and then they also show you the same thing with the minus, plugging in the trig values from the unit circle and expressing it and getting a number, showing you how it's equal. So they lead you. Let's keep going. They'll show us all of them here in a second. Just showing you step by step how they simplify these with values and with variables. And ultimately we get here. Sum and difference identities. If you have sine, two different values, the plus sign yields to add them. The top sign follows the top sign. If it was minus, you would do minus. Now with cosine, it's opposite. Plus sign will give you a negative over here, and a negative will give you a plus. The sign changes. I think it's trying to be color coded, but the red didn't show up very well. It looks like a little burgundy on my image. And then with the tangent, same thing. The top signs follow the top signs. The bottom follows the bottom. Okay, so those are the basic ones we're going to be using. And I think they give you even more examples on how to apply these. Okay, so you have these to look at, and you can search on the internet and find all kind of other examples. But from here, I just want to show them to you. You have them on the Trig cheat sheet. We're going to jump into my math lab and get started.